Hey, I'm Max, and today we're starting the plane shooter tutorial for Unity. Make sure to subscribe to see the future parts of this tutorial and the future tutorials as well. Let's get right into it. You want to create a new project with Unity. If you don't already have Unity, just install Unity Hub from the Unity website. Then you want to click 2D because you're going to make it 2D and input the project name that you want. I'm just going to call it plane shooter. Okay, now that the project is created, let's create a folder for our sprites and input our sprites into our project. To input sprites into your project, you just have to drag them in. You can create your own sprite if you want, but I'll put the one I use for my tutorial in the description if you want to download them. Okay, so here we go. I imported all of my sprites. The first thing I'm going to do is make sure that the game is in 16:9 ratio, so it looks good on monitors. Then I'll add a background so the camera doesn't see just blue. To do this, just right click, 2D object, sprite, and then select the sprite you want for your background. I'm just going to use the game background. And in my case the background is vertical, so I'm just going to rotate it 90 degrees and align it with the camera. I'm going to rename it to background, and I'm going to put it as a child of the camera to make sure that if the camera moves, the background moves as well, so it never sees blue. Now I'm going to add a sprite for my player plane. I'll name it like this, player plane, and I'll put the plane as the sprite. Now as you can see, it is pretty big. We have two options here to make it smaller. We can reduce the scale on both the X and Y axis, or we can increase the pixel per unit. In my case, I'd rather increase the pixel per unit so I don't have to scale it down every time if I want to make multiple copies. Okay, so now I'll place my plane about in the middle, or actually a little bit above, so I don't see the camera over it. And then if I want to be able to move this plane, I need to give it a rigid body 2D. And if we don't want the plane to be able to go above the top of the camera or below the ground, we need to give it a collider. I think in this case a capsule collider may be the best to fit the shape of the plane. Let's try it out. Okay, so as you can see, the capsule is vertical, so I need to set it to horizontal, and now I can set it pretty well to the shape of my plane, just like this. And if you don't see this little square, it's because you need to click here, edit collider, so you can see the little square to change the shape. I also recommend here in the rigid body 2D to set the collision detection to continuous to make sure that the collisions never fail. Okay, so now let's add the ground and test the collisions. I'll just create a sprite, call it ground, and put my wall sprite. Once again, it's vertical, so I have to rotate it 90 degrees, and I'll just put it below the camera so you don't see the rest of it. About this amount of ground should be okay, but as you can see, it looks kind of weird because it's too big, so I think I'll reduce the scale to something like 0.4 and bring it up a little bit, and I think like this it looks a lot better. Now let's give the ground a collider. I think for the ground it's better to have an edge collider, and I'll just edit my edge collider and set it to the shape of my ground. Like this looks pretty good. Okay, now let's test and see if the collision worked. As you can see from our scene, the collision works, but in our game view we don't see anything. That's because our camera is set at -10Z, our background is -1 and is linked to the camera, so it's actually at -11. So I just need to increase that a little bit so the camera sees it. As you can see now, it sees the background, but it still doesn't see the plane and the ground. That's because the plane is at -12, I'll just set it to 0, and the ground is at -16, I'll just set it to 0. But now the background is over the plane and the ground. That's because I need to increase the ordering layer of the plane to 2 and of the ground to 1, and now they're both over the background. Let's play and see how it looks now, and now it looks fine. For the inputs in this tutorial, I'll be using the new Unity input system. Right now you have to import it to be able to use it because the old one is still supported, but I'm guessing in the future it's going to be on by default. So if you're watching this pretty recently after the upload, you might have to go to Window, Package Manager, then click at the top left and select Unity Registry and search for input. You should find the input system, and you just have to click install and it's going to import it. It's going to ask you if you want to restart and disable the old input system. You just click yes. Now you can make sure that the package is installed by checking in project and seeing if input system is here. Now let's make a simple script just to make our plane follow our cursor with a little bit of trust. I'll create a folder for my script to keep things nice and clean. I'll create a C# script and call it player controller. Now you can open this script technically with any sort of editor, even Notepad, but I recommend Visual Code or Visual Studio if you can. Okay, so this is a basic mono behavior. What that means is that you can attach it on game object. Obviously we want to attach this on a player object to make sure that it's the right object being affected by our inputs. Here we have the start function, which, as it says in the comments, is called before the first frame update. This is where we set our stuff that we want to use for the rest of the class. It just runs once when the object is created. And this is the update function, which is called once every frame. The problem with this is that if we do something like movement in here, it will happen once every frame. So if your game is laggy, you're not going to move as fast. If your game has a lot of FPS, you're going to move way too fast. So instead of using update, we actually want to use fixed update, which, as the name suggests, happens every fixed amount of time. It can also help to reduce the lag because doing calculation like physics and movements every frame can be a lot for the computer. To be able to use the new input system, we have to type using Unity Engine.input system. If you are using Visual Studio and you get an error here when importing input system because it can't find it, you might need to go to Unity, Edit, Preferences, and then Regenerate Project Files after closing your Visual Studio and then open it back up. Now we will create a public void mouse position that will get triggered every time we move the mouse. We need to put the parameter input action dot callback context and call it what you want. I'll just call it context. Then we will read the value of the context, which is the event that gets triggered when you move your mouse. And to do that, we just have to do read value vector2, and that vector2 is going to be the position of your mouse. Now just to try it out, we'll do a debug log and log that mouse position, see if it works. Now we just have to set up the player input system to make sure that it works with mouse position. To do that, we just go on a player and add a player input component. If you don't see it, it means that you don't have the new input system installed. Inside the player input, we just have to click create action and then create an action in your assets folder. Go in your assets folder and open the file that was created. By default, you should have move, look, and fire. For our game, we won't actually need move, so you can delete it if you want. We will actually use look to move since it's using the mouse, so if you want you can also rename it move. The only thing we need to change here is delta pointer. We need to change it from delta to mouse and then position. That's because we don't actually want to use the movement of the mouse but the position of the mouse. Now you can hit save and close this. Then go on your player object, go in player input, make sure that your action is put in the first slot of action. Default scheme is keyboard and mouse. And here in behavior you want to select invoke Unity events. Now open up the events, player, and then in move here you can add a function, drag in your player, and select player controller mouse position. If you don't see player controller here, it may be because you forgot to add it to your player object. So if you don't have it, go at the bottom, add component, and then add player controller. I have it here. So now that your event is set up correctly, the mouse position should be called whenever you move your mouse. So this should be called whenever I move my mouse. Let's try it out. So here I'm going to go in the console, and as you can see, if I go at the bottom, you'll see 0, 0, 0, and if I move, you can see it spams the console with a bunch of position. But as you can see, those positions are screen position and not world position, and our plane is at world positions. So we need to transfer the screen positions into world positions. The way we do this is simply by adding camera.main.screen to world point, and we put the vector2 of the mouse position in parameter. So now as you can see, it gives us the world position. So if I go here, it's -8, here it's 8. So that makes a lot more sense than the 500 we had. Now let's add some basic code so we can move the plane using the rigid body. So the first step will be to put the mouse buzz as a global variable because we want to use it in a fixed update. So here we can remove that, and we can also remove the debug. And now we can simply add a private variable for the rigid body 2D and set it in the start. So what this code here does is simply at the start, so when your player object is created, it's going to set the rigid body variable to get component rigid body. And all that's gonna do is go on where the script is, the object where the script is. So player control is on my player plane, and search for a rigid body. So it's going to set the RB to this rigid body here, which is the one attached to the plane. Now we have everything we need to move the plane, so all we need to do is check for the direction. So the way we do this is create a vector and set it to the mouse position minus transform.position, and that is the position of the plane. So where we want to go minus where we are, which is the direction in which we want to go. But as you can see, this one is a vector 2 and this one is a vector 3, so you can't subtract them. So you have to create a new vector 2 with the transform position x and the transform position y. So now we have the direction. All we have to do is apply force in that direction. So rb.addForce direction, and then we have to do time a speed. So we need to add a public float speed, and that should let us adjust our speed depending on how fast we want the player to go. So let's try this out. Before trying it, remember to go in your player control and set the speed to something like 5 to try it out, and we'll see if that works. And as you can see, the plane is going towards my mouse, so that's a good start, and it also hits the ground fine. There's nothing preventing it from going up though, so we might need to fix that. And also you can see that the movement is not really realistic. The reason why the movement of our plane is so strange is because we calculate the direction with the mouse buzz and the plane position. So that means the further the mouse is from the plane, the stronger the force is going to be. So we need to normalize the vector to make sure that the direction is always going to have a magnitude of 1 to make sure it doesn't affect the speed. Let's try it out, see how that works. And as you can see, it does work, but now it's very weak. That's because the vector used to be very strong, but now it's normalized, so it's always 1. So we may need to increase the speed to something like 30, and let's see how that looks. That looks a lot better. But as you can see, the plane, when it goes next to the cursor, it keeps going for a while, and it doesn't break or turn around very fast. That's because there is currently no drag on the plane. Let's try setting that to something like 5 and see how that looks. Now that looks a lot better. As you can see, the plane can easily turn around, and it's not going very fast, but it's going at a constant speed and it's stopping to turn around. Now let's make the plane rotate so that it points towards the mouse so it looks better. To do that, all we have to do is calculate the tan and then set the angle of the transform to that. So to do that, all we have to do is do float angle equals to matf.atan, since we do it with the sides, and then we just put dar.y divided by dar.x, which is going to give us the angle. And then we just set the transform.rotation, which is the rotation of the plane, to quaternion, which is the thing that's used to set angles in Unity. And then we just do Euler to set it with a vector 3. And that's very complicated for no reason. Basically, you just put your angles here. So we do 0, 0, and x and y. And then in z, we put the angle. So we get the angle of the direction, and then we set the transform rotation to that angle. And I almost forgot, you have to do times matf.rad to degree, because this gives you a rad answer. So now, as you can see, it works for the right side, but it doesn't work for the left side. So we just need to add 180 degrees on the left side. So here we just do if direction x is less than 0, then we do angle plus equal 180, so that it flips the plane around. There you go, now our plane is following our cursor very well. And let's actually make it a little bit better so we can see it better. And that's the end of the first episode. Thanks for watching. We made a plane that follows our cursor and turns around and can hit the ground. Make sure to subscribe if you want to see the next parts of the tutorial so we can finish this game, and maybe to follow some other tutorials for the next game I'll show.